All right, continuing forward on our more about strings. Sometimes I'll label this as strings, because it's just strings everywhere, constantly strings. I should actually call this string theory. That'd be a lot of fun. Anyway, sorry, being a little bit of a nerd there. All right, so we're going to jump back in here to string concatenation. So again, this should be a little bit of a review. We've talked about this and how we can actually do this. So again, string concatenation, appending one string to the end of another string. Okay, very simple. We've done it before. So essentially, and every time we use print with that plus value in there, we're actually doing string concatenation. So I can ask a user for first name. I can use ask a user for a last name, and then I can use the plus sign to go ahead and concatenate those things together. So essentially, I'm just putting 2 strings or 3 strings or 5 strings or n strings together, okay? And I'm just sticking them end to end. So as we've already seen, we use the plus operator to produce a string that's combinations. We can also use the augmented assignment operator, the plus equal, okay? So essentially, plus equal would be name plus equal, some string is the same thing as name equals name plus some string. Okay, so you can also use that to just continually and progressively add on to the end of a string as you're doing, say, a for loop or something like that. Okay, so we can use the plus sign, we can use the augmented assignment operator as well. Now again, strings are immutable, and I need to make sure that we get this through our heads, because in Python, the fact that strings are immutable is important, especially if we're doing big data. Okay, so we're doing Python for data analytics. When we're working with data, especially data that's in the cloud, we're going to be using lots and lots and lots of data. So it's very, very important that you understand what you're doing with the memory inside of your program. Now, the fact that strings are immutable is important because every time you change a string, you don't actually change the string. You create a new memory location and save that change into that memory location and then move the name of the variable to that new location. Okay. Reason why that's important in big data is if you're doing too much with strings, it can actually cause your program to slow down exponentially. Okay, so it's important to remember strings are immutable and consider that when you're building your programs. Now, again, functionality is extremely important. If you need to use strings in that way, that's totally fine, and in fact, you will. But if you're going to be creating some sort of a data analysis program that's going to be working with gigabytes or terabytes of data, you want to be very, very, very considerate as to how you're doing that. So again, immutable means once they're created, they cannot be changed. Okay, so concatenation doesn't actually exist in Python. What you're doing is, let's say, first name plus last name, you're literally just creating a new memory location. You're putting first name and last name into that new memory location, and then you're changing the variable name memory location to that new location. If you remember way back in chapter 1 in that introduction to how sort of memory works. So again, they are immutable. So that means that you really can't use an expression where you use string index as a new character, sort of like we do in lists, right? Because lists are mutable, strings are not. So if you try to go into a string and just change a specific character, it's actually going to give you an exception. I'll go ahead and show you what that looks like. So in this way, strings are different than lists. They're more like the tuples that we talked about. Tuples are immutable as well, so you can't really go in there and change certain elements in that string. You actually have to create a new object and then manipulate that. Okay, so you cannot use the expression of the form string square bracket index equals a new character. Okay, that's going to raise you an exception, and we'll go ahead and see what that looks like because I will demonstrate that to you. Okay, so to just sort of visually demonstrate what this looks like, okay, so I have the name Carmen here. Okay, so we can think that Carmen exists somewhere in memory, and we can call this little box that memory address. What if we call that 1? Okay, so now name is pointing to memory address number 1. Okay, so whenever I want to concatenate, okay, so we're going to add Brown to the end of Carmen. Okay, so I have Carmen, I have Brown. Now we are using name equals name plus Brown. We could also do name plus equals Brown. Okay, so the augmented assignment operator works just as well. But this really demonstrates the purpose. So what ends up happening is at memory address 1, Carmen still exists. But what we do is we add Carmen and Brown together, save that at memory address number 2, and then change the value that name points to. Okay, so imagine now you do a loop that is, I don't know, 1 billion values long. Okay, that's going to mean that you're going to, and you're concatenating a string each time. Now imagine every iteration of that billion, you're creating a new memory location. Can you see how that would fill your memory up immensely fast? Okay, so that's something that you really want to make sure you're considering when you're doing your data analysis. Whenever you're messing around with, building strings or concatenating information, you want to be able to use mutable constructs so that in those memory locations you can just switch things out. Okay, so one of the best ways to do this is you could just sort of convert your string to a list. Okay, and you can do that with a for loop, and I can kind of show you how to do that because we know that a list is mutable. So that means we don't actually have to be messing around with this immutable concept. Okay, so remember what you're doing and pay attention to it. Now, again, you can mess around with all of these all you want. If it's a small program, you're not going to be iterating, say, 1,000,000 times or something. You don't necessarily have to worry about it. Modern computers have lots and lots of RAM and lots of capabilities, especially when you're on the website, when you're on a server. However, efficiency is one of the most important elements in data analytics because if we have two algorithms to do data analysis, and two programs that carry out those algorithms, the one that goes the fastest is always the best. Okay, so it's something to just go ahead and consider sort of fine-tuning. So we also have string slicing, and this is essentially where, let's say I have Adam Spanier as the full string, and I want to go ahead and break that up into first name and last name. So what I can do is I can actually use string slicing. I can also do string splitting using delimiters and tokens, which we will talk about at the end of this chapter. But I can also do string splice, right? So I can actually choose the indices, splice that, and go ahead and create a new string with it. Okay, so to slice is, or a string slice is, a span of items taken from a sequence known as a substring. So we can also slice lists, and we've already talked about that. So I can slice a string just like I can slice a list, just like I can slice a tuple. Okay, so that's essentially just grabbing data out of it and writing it to a new place. So the format here, obviously, much like indices, you can do string, of an index. So that's essentially just going to give you the one character. You can also do the string start to end. Now, if start isn't specified, you're just going to get a 0. So you can start at the beginning and go to the end. If end is not specified, then it's going to start at the end and come backwards. And I will show you sort of how that works as well. Now, again, slicing expressions can use a step value as well, and negative indices work. So it's just like that range function that we have been talking to. Now, keep in mind, this is Python, so everything is consistent. This is inclusive, so we will start at 0. End is non-inclusive. Okay, so that means in this particular value, you can put len string. Now, the reason why you can do that, I want you to think about that for a second. Since end is non-inclusive, let's say the length of the string is 13, which means the top index is 12. But since end is non-inclusive, it's only going to go up to 12, not to 13. Okay, so I want you to think about that and digest that a little bit. So you can put len string here if you want to. Okay, now you don't have to, because you can just, if you want to go to the very end of the string, you can just leave this blank and give it a start location. Okay, so there's a lot of cool little bits and pieces that we can do with that, and I'll go ahead and demonstrate that to you probably in the next video whenever we're chatting about that. So again, you can use other operations to be able to sort of search strings. And this in operator is extremely helpful. So we've seen this obviously with lists already. So I can have a list of first names, for instance, Adam, John, whatever. And I can go if Adam in list print name, right? So I can actually search a list for a given name. Now you could do the same thing in strings to find substrings, okay? So let's say people let's say you're doing analysis on a big data set with words in it. And it's a bunch of, I don't know, tweets or something. And in this data set, you're actually trying to find the occurrence of the word, well, let's just go with cars. You're looking for Koenigsegg, because I love cars. You want to look and search for a bunch of the mentions of Koenigsegg, which is a high-performance car company, which is really, really cool. So then you can actually create this loop that loops through all these tweets that have been converted into strings, and you can say if Koenigsegg in this particular string, then you would say I found it, and you could even save that into a new list, right? So it allows you to be able to parse large strings for substrings and be able to save the values in the data from that result, okay? And I will show you that as well, okay? So obviously, if you can use if string 1 and string 2, you can also use not in, okay? So similar, you can use the not in operator to determine whether one string is in another string. So we're going to go ahead and stop this video for now, and I'm going to go ahead and demonstrate some of those concepts to you in the next video, and then we're going to jump into string methods. We'll see you on the other side.